When I learned that there was a company testing an innovative renewable energy platform that generates electricity from wind using kites rather than wind turbines, and in County Mayo, just down the street from where I live, I reached out and told them of my interest in doing a video for my channel. They did cooperate a bit in the making of this video, and I'm here to talk about Kitepower. What are they doing, how's it going, and my thoughts on their prospects. First, it's important to make clear that I selected Kitepower because of their test site near where I live. They're part of an industry known as airborne wind energy, and there have been at least 15 companies working to develop systems like Kitepower's. Some, like Makani, burnt through large amounts of cash before crashing like a novice kite surfer who caught more wind than they can handle. Kitepower is based in the Netherlands, a country famous for wind power going back centuries. Water pumps driven by the wind have shaped the very landscape of the country. But when another company developing a Kitepower system went bankrupt, they were able to get a test site in Ireland that was already up and running and available at fire sale prices. The site is in the middle of a bog, land that's best left undisturbed for reasons I'll cover in a future video. And one of the great things about a system like Kitepower is that there's no need to dig holes and pour concrete. You couldn't set up in a forest, but a flat, unobstructed land like a bog works perfectly. The architecture of the product has four main elements. First, the ground unit, which is about the size of a shipping container and houses the generator. It just needs to be placed on reasonably flat ground. Next is the tether and the kite control unit, which is about a cubic meter in size. The final element is the kite, which is like a standard kite surfing kite, except about 6 times larger at 60 square meters. It's connected to the kite control unit, which is acting like the kite surfer, taking in data about the situation and deciding how to pull on the kite. The operations team is entirely made up of former kite surfing instructors. One of them described his job as teaching a robot how to kite surf. The current design of the kite sets up in about an hour and launches with a single push of a button on a tablet. From there, the operations is controlled by a computer in the kite control unit, which takes input like the tether length and the angle from the ground unit and location and orientation from the kite to determine how to pull on the control lines for the kite. Once the kite is in the air, it flies a figure 8, pulling the tether from about 200 meters to 300 meters in length, which drives the generator and produces about 30 kilowatts of power. Once the kite has reached the end of its tether, or at least as far out as programmed, it automatically moves directly above the ground control unit, which reduces the force on the tether as the kite hovers. The generator switches into motor mode and easily pulls the kite back down to 200 meters of tether length. And then the cycle repeats again and again. So will kites play a significant role in decarbonizing our electricity grid? They have several advantages over traditional horizontal axis wind turbines. If you have the space and the wind, you can set them up just about anywhere with minimal impact. No pouring concrete or erecting towers visible from far away. Places like bogs or sensitive biomes that would be off limit to traditional turbines aren't a problem for the kites. You can set them up quickly, in about a day, with no need to prepare the land. This compares to months for a traditional turbine. But there are some issues that will prevent their scaling. Their current system can generate up to 100 kilowatts, compared to about 3 megawatts for a traditional utility scale turbine. So it would take about 30 of these to equal one traditional turbine. Future designs with larger kites and flying at higher altitudes could easily triple the power output, but that's still a 10-to-1 ratio. But while 10 of these systems might be cheaper to build and deploy than a single large utility scale wind turbine, there's still a problem. The kicker is that these kites require significantly more labor, because when the wind dies, the kites come down and someone will need to prepare them to relaunch when the wind comes back up. You might need a worker for every kite to get them back in the air quickly. By comparison, a small team can serve a large number of traditional wind turbines, and solar farms require even less labor. So the labor costs alone will likely prevent this design from being cost competitive with solar and traditional wind turbines. But there are niches where kite power might still make sense, not competing with the grid, but with diesel generators at remote sites. That's where the first two pilot projects have been, remote construction sites where the alternative is to take large industrial batteries off-site for recharging or trucking in diesel fuel to power a generator. Here, Kitepower's competitor to replacing diesel is solar photovoltaic. Kites have one big advantage: you can set them up in a day. Deploying a solar array can take weeks, less than a traditional wind turbine, but still longer than a kite. So if you have long-term needs like powering an isolated village, I suspect that solar will be the winner over a system like this one. But if you only need power for a few months or you need it up and running quickly, then kite power might be a better fit. In addition to construction sites or festivals, I think disaster recovery might be a good market for systems like this. Imagine after an earthquake or a hurricane, setting up a kite to provide power to critical needs like a hospital might be the way to go. There, the difference in setup time could be a matter of life and death. That's why kite power was selected by the UN World Food Program for the Innovation Accelerator Bootcamp. But until kite power develops a system that can land in low wind conditions and take off again without human intervention, they'll be restricted by the labor costs to being a niche player. The size of this market is uncertain, and my earlier video on microgrids in Africa showed there's a significant opportunity there. If they can reduce their labor demands to something similar to a traditional wind farm while keeping their material costs low, then the sky's the limit. Otherwise, they'll be competing with solar power and other airborne wind energy solutions for a share of the microgrid market. But for now, if you're trying to figure out how to power an isolated site, you just might say, "Oh, let's go fly a kite." The responsibility for the content of this and all of my videos rests solely with me. The analysis is mine, as are any mistakes. Like always, I include links to any available material in the description. If you've learned something, you can like and subscribe and watch more of my videos. And please share this video with everyone you know who has watched a kite surfer take to the air and thought, OMG.